This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 117, using Ansys fluids to design better rocket engines with Ursa Major, and news and events from around the Ansys world. Greetings and salutations from my home on the very southern edge of the city of Phoenix in a suburb called Ahwatukee. It's a lazy Sunday morning and the last day of April, and my name is Eric Miller, and I'm one of the owners at PADT, a Ansys user with 35 plus years of experience, and your host for these podcasts. Before we get to our interview, which is with an engineer from a rocket engine company, I want to talk a little bit about the space industry. Last week, I was lucky enough to go to the Space Symposium in Colorado Springs. This is one of my favorite events because, one, it is about space, and I still have it is a childlike attraction to rockets, satellites, and spaceships and all things space. And two, because this show is full of people from companies, military organizations, and government agencies who are doing real space missions. These are the people not just designing and building the hardware, these are the people planning the missions and managing these massive projects. It's kind of hard to put into words, but this year, this conference was a little bit different. The best way I could describe it is that for the previous 3 or 4 times I've been there, we all talked about what could be, how we need to work together or get ready to do things. In a few cases, we talked about real missions on the horizon. But that completely changed this year. The talk was not about when, but how everyone would accomplish the missions they wanted to do. Space stations, lunar landers, rocket engines, ground stations, incredibly sensitive sensors, and interplanetary exploration. The space industry is exploding in so many ways, and I have to say it's just plain cool. So if you're in the industry, I don't have to tell you to eat a good breakfast and get some sleep because things are getting really busy. And if you just enjoy following what is going on in space and find some good resources, I like space.com, and follow along as we do incredible things in orbit and beyond. It really is go time. All right. So with that said, let's move over to our interview. And we're actually lucky enough to talk to somebody that is in the middle of that go time, getting engines ready to go into space or into orbit. And we're lucky enough to have a user from one of PADT's customers, Ursa Major, to come and talk about how they use Ansys fluids to design better rocket motors. And I will let him explain more. I want to welcome everybody to our discussion today on Ansys fluids. We are lucky enough to be joined by one of our fantastic expert application engineers, Daniel Chaparro, and also one of our customers, Jim Reyenga from Ursa Major. Hey, guys.
Howdy. Hey, how's it going?
And Jim, you're calling in from Colorado, and Daniel, you're in Texas, right?
Yep, that's right.
Hey, great. Well, it's hot here in Phoenix. I don't know about you guys, but spring is over. We got the AC on now. But let's begin, Jim. If you can just give a little bit of background on, who you are, how you ended up going into simulation, and what you do right now at Ursa Major, and a little bit about Ursa Major too. I think I know I kind of started because I know a lot about you guys, but maybe our listeners don't. So you can add that in as well.
For sure. So at Ursa Major, we are a startup company focusing on high performance, high efficiency rocket engines to sell to others that are integrating into overall new launch vehicle, which is exciting and super challenging.
Very.
So I'm a principal Turbomachinery Engineer at Ursa Major, and my responsibility is the technical capability of our turbomachinery, which has a lot of rotating fluid and structural challenges. And prior to that, I actually used to support Formula One kind of operation and for turbochargers. And in that case, really needed to hammer on CFX and fluid simulation capabilities because we were chasing every bit of efficiency. The dynamics are a little bit different in rocket engines that were more after reliability than efficiency. But those tools, when used in the right kind of agile framework, can really go from your first conceptual 1D design to some pretty sophisticated and high-performing rotating components.
Wow. Can you say which Formula One team?
Yeah, Ferrari. I worked for Honeywell Turbo, but we were
Okay,
the
you're supporting
uh,
Ferrari.
yep.
That doesn't suck. No, no.
No,
Pretty
it was
cool.
exciting. It was hard too, but it's
I
exciting.
very yeah, it's kind of glamorous for those looking on the outside, but that pace must be. I've known some folks that worked for Williams in the UK side on the body aerodynamics through Ansys, and it was brutal, right? It's a
Hmm.
lot of work. Yeah,
Yeah.
yeah, yeah. Very, very cool. Um, and Daniel, you haven't been on for a while. Why don't you give us a little bit about yourself as well?
Sure. I'm an application engineer here at PADT. I specialize in fluids, so like CFX, like Jim mentioned, and Fluent, as well as some other tools that we have under the Ansys umbrella. My background before PADT is kind of a mixed bag of things. I worked at the NASA Ames Research Center in California for a few years, working on kind of morphing wings. And I also worked at Northrop Grumman, Turbomachinery for marine applications, so like aircraft carriers and submarines, things like that. And Turbomachinery for wind applications, so like cooling of generators, um, and a little bit of automotive as far as hydraulic hoses and power transmission belts. So yeah, so kind of a mixed
Cool.
bag of things, but they're all kind
Mhm.
of CFD type of roles that
Yeah,
I've had.
related. Cool, cool. So at Ursa Major, I think we started with you folks when you were a startup. Could you share what you can share, how you use Ansys fluids, what kind of simulations you do and the kind of value you get from those things?
Yeah, absolutely. And so I think like the key thing that we get, well, the the key thing in the turbo machinery that we need to predict is both
Mhm.
our you know operational head coefficient, because it drives so much of how the cycle anchors,
Mm.
as well as cavitation capability,
Ooh.
and that's the really tricky one.
Mhm.
And it's always a balance of how much do you trust the simulation versus how
Mhm.
much time and effort can you invest into removing the simplifications and assumptions and getting closer to reality. We can't take decades to run a simulation, but we
Mhm.
also, if we produce results that are not trustworthy, they're not useful.
Right. Right. And are you doing combustion, rotating equipment, cooling, all that stuff using fluids?
Uh, so within my group in turbo machinery,
Hmm.
it's the rotating
Okay,
components and
just
the
rotating
static
components. Okay.
structures around it. Yeah.
Yeah. Okay. Very cool. Very cool. And I was lucky enough to visit your test stand when I was last out there. And yeah, I need to be there one of these times. We just missed a firing, but I need to be out there
Oh,
one of these times when it was firing because from in the building we could feel the ground shake. So this is a lot of power. It's a lot of power. Very cool stuff. So what in your daily use of Ansys fluids? Well, let me ask a question. Are you using mostly CFX still, or have you switched over to Fluent, or are you using both? Where are you with that transition?
yeah, we're mostly CFX. It's an
Hmm.
interesting dynamic. There's a lot of heritage in rotating
Hmm.
machinery with CFX,
Yep.
and it seems to handle some of the simplified type models where you run a single passage quite well.
Hmm. Hmm.
Um, but it's also clear that there seems to be more growing maturity on the Fluent side, and
Hmm.
so it's something that we continue to keep a pulse on. But going back to simulations you can trust,
Right.
with our background, we know what we're getting with CFX, but we're kind of perpetually Fluent curious. It's just that's a lot of trust that we would have to rebuild and process.
Hmm.
Yeah.
I like that. Fluent, curious. That's good. That's good. And it's true, right? I mean, there's decades of rotating equipment experience on the CFX side, and built as a rotating equipment tool initially. So, yeah, it's definitely there. Cool. So, what's your favorite, um, I don't know, feature, application, whatever you want to
Can,
call it in CFX?
can it be my simultaneously favorite and least favorite?
Yeah, that's
Um,
the best. That's the best. Yeah.
yeah.
Love it, hate
Uh,
it. Yeah.
Blade Gen. It is great, and not the one
Awesome tool.
integrated into Design Modeler. It is
Mm.
is a really good tool, and if I could lobby anyone, if we could, you know, There's more it could do. That would be great.
Big fan of that tool. Used it years and years and years ago. It was way ahead of the competition. And you're right. When it does what you need it to do, it's like magic. And then when it can't do what you want, it's like, oh man.
Yeah.
Yeah, I hear you on that one. Daniel, what's yours? We haven't asked you that question in a while. What's your favorite CFX tool?
CFX tool. I mean, I think I really value the post-processing part of it. Like, I think everything's available to you as soon as you're done solving it. You don't have to create like your custom coordinate systems. It has the information that you need as a tool machinery kind of designer. So I think that's pretty clever.
Yeah, agreed. Yeah, I do. I don't do it very much anymore, but I did find it a very intuitive and powerful post processor, to kind of get in there very quickly and dig deep. Yeah. True.
Yeah, Jim, I'm wondering how early in the design and how late into the design do you use CFX? Is it throughout the whole design cycle or mostly preliminary?
It's definitely throughout. One of the things that we try to focus on in the team is kind of like right sizing each step of the simulation. Because spreadsheet calc can get to grossly what we want quite quickly. And then we kind of like try to introduce complexity and simulation robustness gradually as the design matures. Because we might want to kind of refine the gross blade design, and we really don't care about what's the volute doing and what's the inlet manifold doing at that stage. And then as we get more mature in the design, we do start introducing cavitating flow, transient analysis, surface roughness, and all the kind of secondary flows. But I think it's really critical that if you right size each step, you can use the tool quickly and iteratively at the right kind of maturity of the component.
That's really important. I'm really fixating on that idea of right sizing the simulation, right? Because I think as simulation engineers, we want to get in there and get it just right, and sometimes getting that 10% costs you 90% of your time, right? So you're good enough with just getting that initial thing done.
Yeah. And we want the accuracy at the end of the day, but there's a long road from days zero to the end of the day.
Yeah, very good point. Really good point. Yeah, good. So we talked about your favorite and kind of least favorite because it's not complete. But what else? Sometimes the Ansys developers do listen into this podcast, and I'm wondering if you have anything you'd like to ask them besides putting more effort into blade gen that you'd like to see in the CFX tool set.
Yeah. Call me on blade gen. We'll talk a long time. That's fine. I think dealing with robust ways to simulate cavitating flow is for me a little bit of a holy grail. Is you're prone to a lot of simulation numeric explosions. We've got a couple of tricks we've developed over the years that help with that. But anything that can make that more foolproof. And then I think there's since we deal with kind of tricky thermodynamics with the cryogens in cavitating flow, using real gas property homogeneous binary mixtures is I think still needs a little bit ironing out in CFX. And so we're not quite there on that yet.
Okay, cool. I don't know, Daniel, have you looked at that at all or gotten involved in any of that cavitation stuff? Is that something that's being explored, or is it something we need to dig deeper into?
Yeah, I think I would need to dig a little bit into it. I think that's yeah, I haven't had too much experience with that myself.
I think it's one of those things that in fact I remember being in meetings going, well, we can't do that. And now we can. So now we have to figure out how to do it better. I think that's kind of where we are on that journey. It's as we add these capabilities, really getting them fine-tuned to the data, and maybe looking at some of those government codes that are focused on that as well. So good place to start. Well, I'll definitely put my 2 cents in on that. I think it's important, and we're seeing it more and more as people are pushing the envelope on performance on these engines.
And I would just kind of reiterate, like the commercial codes like CFX, to me, there's so much value in being not necessarily fast on the numerics, but fast in the workflow process. That those more academic codes that might be focused on a
Hmm.
specific subdomain just aren't you know from the human factors point of view fast. And I think so much of our time can get eaten up
Yeah,
just trying to use those things.
good point. Really, really good point. Yeah, that's really cool. Um, One last question that I like to ask with an experienced engineer like yourself is, if somebody is in college or about to graduate or just graduated and is interested in doing fluid mechanics for rocket engines, um, what advice would you give them, including do or do not work for Elon? I don't know what the answer to that question
Well, touch the latter part. Um, uh, it's a learn to get experimental with the analysis.
Mm,
But
hmm.
for myself, maybe it's just the way I learn, but just going through a really disturbing number of iterations and design with lightweight models has helped me
Hmm.
build much better intuitive understanding of how the flow and structures interact. And it's pretty universal, whether
Hmm.
it's a turbine pump, compressor, and compressible or compressible flow. And just you get those through practice, and iterations is practice.
Mm.
And so I think learning to be analytically experimental is really can help build a strong intuitive understanding of how to make fluid dynamic components.
That's really good advice. Did that bring anything up in your mind, Daniel, for advice for folks listening in that are just getting into the world of high performance CFD?
Yeah, it's kind of like what if mentality, I think is critical. Like what if I change this assumption, or what if I change this part of the geometry?
Hmm.
Like don't just trust what's in the documentation, but really learn it by trying it.
Hmm.
And definitely like the lightweight aspect of a model is important, because you can't just try and fail with a model that takes 2 weeks to run, right? Like you need to be able
Hmm.
to do this and something that you can learn from, but at the same time it runs in an hour or less, something
Right.
something uh easy to run. So yeah, that
Yeah.
definitely resonates. I think that's great
Good.
advice.
Yeah. Very good. Well, excellent. I can't wait to come see you guys soon. Do you have any launches coming up? I can't remember what your schedule looks like right now at Ursa Major. I can't. One of your customers, I think, was coming soon, right?
Yeah, sorry, my laptop went to sleep for like a
Ooh.
minute, so I may have missed.
No.
I heard Daniel having a models that don't take 2 weeks to run, and then it went to sleep.
Oh no. Yeah. Yeah, I was just wondering if you guys have a launch coming up. Anybody using your engines?
Um, Gosh, I don't know what's public, so
Okay,
I'm
okay.
just
Then
gonna
we
be
won't we won't we
quieter.
won't go into that. Well, Google it if you want to know.
Yeah.
Huge fan of the business model. We're here to talk about Ansys, but Ursa Major is making these really amazing engines that other launch providers can use on their spacecraft, rather than everybody having to reinvent the turbine wheel over and over again. And I think it's a great business model, and we're excited to see your guys' success and hope to see more of it. All right.
Much
Well,
appreciated.
yeah. Well, thanks you both for your time. I'll let you get back to work. I appreciate the talk and hope to see both of you soon in the not too distant future. Thanks.
Cheers.
Bye.
Thank you. Bye bye.
Hopefully, this will give you some ideas on how better to use Ansys Fluids for your products. You can go to ursamajor.com. I highly recommend that. Right there on the front page, they've got some pictures of the engines that we were talking about being tested. I was lucky enough to go out there and visit them to talk about a consulting project, and they took us out to the test stand. It wasn't running at the time, but it's kind of cool to see those things going. A lot of power and energy in a very small package. But anyway, check out ursamajor.com and learn more about what they do. So let's get to our commercial before we look at news and such. Since we rebooted the podcast in January of this year, we talked about PADT, kind of in general, Ansys training that we do here, and then about our sales team and the experience of buying Ansys and Flonex software from that team, and then in the last episode about Ansys mentoring, which brings us to kind of the next logical thing to talk about that we do here at PADT in the world of Ansys, which is simulation consulting. An important part of what makes buying your Ansys software and support from an elite channel partner like PADT is that we also have a full team that uses Ansys software to do consulting. And so that helps us support you, but it also means when you need help, when you need have overflow work or work you don't really have experience with, you can come to us. So that's why customers from all around the world, and yeah, we just have a project that started with a Swiss company right now, they come to us because our expertise with the tools and our understanding of engineering fundamentals and how the results from simulation can be best used. We're not just putting in a black box, running the model, here's the results. We understand why you're doing the simulation, what you're trying to get out of it. Our engineers can provide structural, thermal, fluid, electromagnetic, optical, and multiphysics simulation as a service. And don't forget that includes LS Dyna and some of the other products out there besides the core Ansys products. We've been doing this for 29 years. Reach out to us at consult@padtinc.com or give us a call at 480-813-4884. Like I said, you don't have to be near us. We do work for people all around the world. So give us a call, send us an email, and let's talk about how our engineers can supplement your staff and help you with those simulation jobs that you don't have time or the resources to get done. All right. Before I get to the news, I was looking at our podcast page on Podbean. We use Podbean to publish this thing. And I noticed that we hit a milestone. Over 1,000 people have listened to our interview with the founder of Ansys and the person who wrote most of the original code for what we now call mechanical APDL, Dr. John Swanson. That episode went over 1,000 listens. So this is a bit of a milestone, and I encourage any of you who have not heard that interview to do so, especially if you're new to Ansys. I think it's kind of important to understand where it came from. John's a wonderful human being, a really smart guy, funny as heck, and it was a great interview, and you'll learn a lot about how the company started and what a cool person John Swanson is. So it's episode number 35. If you just search Swanson Ansys podcast 35, it'll show up in the search engine, or you can go to whatever your podcast delivery system is and look up episode 35 of all things Ansys. Thousands of major milestone for such a small niche of the market, and I think it's important, especially those of you who are new users. Or are new to Ansys. You don't have to be a new user, but a new Ansys user to kind of understand where this company came from. That's this big part of our lives now. So, Ansys stock. It's been sort of flat since our last episode. It closed on April 28th at $313.92. So that's the Friday before I'm recording this. It did hit 332 at the end of March. So that was since our last podcast was released. And that's a price of the stock ANSS that we have not seen since January of 2022. So it's getting back up there. And over the past 12 months, the stock is up 9.26%, and for comparison, the S&P 500 is down 3.55 over the last 12 months. So not bad, and it's good to see it's up above the broader market, and we'll keep our eye on it and see how it does as the global economy changes and all these industries that use Ansys get more news, like space, e-mobility, semiconductor. These are all big growth industries right now, and Ansys plays a key role in all of those. So we'll keep our eye on it. So speaking of semiconductor, we've got two important stories about Ansys and TSMC, and we don't really cover the former Apache products too much on the podcast. It's one of the few areas that PADT doesn't do a lot of work in, but I think it's important that we kind of know what's going on in that space because it impacts the rest of us a lot. So if you're not from Arizona, the other reason why I'm covering this story is if you're not from Arizona, you may not know that Taiwan Semiconductor has decided to open up a foundry here in the U.S., several fabs, and they're going to do it here in Phoenix. And so they're talking like 5 gigantic fabs here in the desert. TSMC is now part of our tech ecosystem here in Arizona, and we're very excited about it and all the things that come with that. And a big part of that is that TSMC is a big Ansys user. So, like I said, they're a foundry. They basically, people who design semiconductors can go to them and say, make my semiconductor for me. So they don't have to, people that design the semiconductor don't have to have their own fab. And the way that works is they publish, how do you design a semiconductor chip or whatever semiconductor thing you're making that uses the processes that we have available. So, kind of design guidelines and design tools. And they partner with people like Ansys to say, if you use this Ansys tool, here's how you use it, and we approve of that. And it's called a reference flow. And on April 26th, Ansys, along with Synopsys and Keysight Technologies, announced that they have a reference flow to use tools from all those companies to design and simulate RF chips, radio frequency chips, using a new manufacturing process. If you're a semiconductor person, this makes sense, but it's 16 FFC. This is big it's a process that people are excited about, according to the story, for 5G, and also radar sensors for things like cars and satellites and safety systems. So it's a frequency range, a new frequency range that people are pretty excited about, and you got to simulate it, of course, and design it before you get it into the fab, and they got this new process to do that. And then the next day, the TSMC and Ansys also announced that the Ansys simulation tools, RedHawk SC and Totem, can be used to simulate the power integrity on another process called the N2 process. So this is another chip manufacturing capability that TSMC offers its customers, and Ansys tools integrate into making sure that those tools are designed correctly. So kind of cool. Hope to see more of that. So the relationship between TSMC and Ansys just keeps getting stronger. The next story is much more important for users that generally listen to our podcast. I'm really excited about this because my kind of background, a lot of what I did when I was a heavy user of Ansys was customization, especially with using APDL and then writing external Fortran and C to drive Fortran. Well, finally, all of the customization stuff has been put in one place. Ansys launched something called the Ansys Developer Portal. So, like I said, it's one place where you can go, and everything that has to do with customizing or connecting Ansys products to other products is documented, along with, there's a knowledge base, so you can ask questions, so you're not over on the other knowledge base, and there's a forum as well, or you can look up what other answers are on the knowledge base, and you can ask questions on the forum. And there's also a GitHub repository, so you can get at the source code that Ansys is sharing with everybody. So this is really cool. One place. It's a real commitment to the development community. I'm going to bring it up right now to tell you what's there. So the most important thing is, of course, the documentation. So Ansys has APIs for a couple products. OptiSlang is one. They have a REST API for OptiSlang. If you don't know what that is, don't worry. But if you do, that's really cool. It's a modern interface for getting data in and out of applications. And then the AV Accelerate product, which is an autonomous vehicle simulation tool, it also has APIs, so you can hook up your sensors, your sensor layout, and your lighting systems to that tool. Then there's all these client libraries. They're basically the one that I'm most familiar with is the Ansys system coupling, say. So Ansys Mechanical, it's a Fortran library for coupling systems. There's also, so that systems coupling comes in C, C++, Fortran, and Python. There's also the data processing framework for Ansys, which is another library that allows you to access things. And then Ansys Insight has its own tools as well. Then on the open source side, which is the PyAnsys side of things, all the PyAnsys stuff is in one place, and there's a whole bunch of them. So do check that out. Pretty cool stuff. That's at developer.ansys.com. And there's also, of course, the knowledge base and the forum and the GitHub. So everything in one place. Check it out. That's kind of big news. Maybe when it's a little bit more mature, we'll have somebody come on and talk about it. We'll see if we can get some time for that. we don't really have any PADT news. The only press release we did since the last time we talked was we're going to the Space Symposium, but I already talked about that. So that's done. And then let's talk about blogs. So Ansys had a bunch of cool blogs over the last month, but the three that I picked to talk about is, and this is kind of relevant. It's not about space, but it's about startups. So Ursa Major started with PADT as a startup. They were part of the Ansys startup program. And now that they're a large company, they use a lot of Ansys. But it was a great way for them early on when they didn't have a lot of money and didn't have a lot of people to get access to the full capability of Ansys. So if you are in a startup or know people in startups, do check out the article. Ansys Startup Program continues to soar globally with added incentives. So they've added some stuff to the program. Do check it out. I'm a huge fan of the startup program. A couple of our big customers now at PADT started with that program, and it's kind of cool to see that. The second one is called What is Automotive Noise Vibration Harshness, or NVH? So if you're an automotive dynamics person, you know what this is. You could probably write this article. But if you're not and you hear people go NVH, NVH, because maybe you're working on motors or maybe you're working on suspension parts or something, maybe you're working on the radio, or you're doing aerodynamics on the stuff that sticks out of the car or the airplane. NVH is basically what the user perceives from a noise, vibration, harshness standpoint. And there's a really good article, I recommend it even if you're not in the automotive business, because it's kind of helped me understand as I get newer cars or I rent newer cars, how that noise, vibration, harshness has been improved using simulation over time. It's kind of cool to look at it from an engineering standpoint. And then last is an article that we are happy to see because we often get this question from new users, especially design engineers who are not so familiar with simulation, and they get into a solver for the first time and they ask the question, what is equivalent stress? And so somebody from Ansys's discovery team went ahead and answered that question and really kind of explained, and it's not a bad refresher. I think a lot of us have been doing this a while. We're just like, oh, yeah, we use equivalent stress, but why? What is it? Kind of remind yourself of what it is. So that's the Ansys blog. Over on the PADT blog side, we've got also have 3 Ansys-related posts. Everybody's been pretty busy. Alex Gershon published a new post on using PyAnsys, speaking of development. This goes over how he used some PyAnsys tools for a consulting project that needed a way to import some really kind of random geometry. The guy was using Rhino. If you don't know what Rhino is, it's a really cool CAD tool that is great for funky shapes, kind of organic, crazy shapes. And it also has some really strong automation and scripting capabilities. So, but it's not necessarily considered a mechanical CAD tool. It's more of a creative tool. So there aren't some existing capabilities to get that data from Rhino into Ansys. So Alex, being Alex, wrote a PyAnsys script to not only load the geometry in, but also data that's created using the scripting capabilities in Rhino. So check that out. Really good example of leveraging Python to drive Ansys. Then Josh Stout published an article called 4-Way Multiphysics with Thermal Deformation Mapping to Ansys HFSS. So yeah, he hooked up 4 different tools, basically 4 different physics to model this simulation. And it's a great example. Mostly we do 2-way, right? We hook up fluids to solids or maybe thermal to electrical. In this case, he hooked up a bunch of stuff. So check that out. Good article. And most recently, Ted Harris, who's been on this podcast, and you should know he manages our technical support team that are often on this podcast. He did a post called The Best Ways to Contact PADT for Support. So over time, we just kind of assumed everybody knew how to get hold of us if they're one of our customers and what's the best way? Do I call? Do I email? Do I go to the website? Well, Ted answers those questions in that blog post. So if you work with PADT as your support provider, do check that out. And then the next thing I want to talk about is events that we have coming up. We do have a webinar on May 10th. That is Signal and Power Integrity Updates in Ansys 2023 R1. So that is our next webinar. We don't have any shows scheduled for May that I'm aware of, but we will be going to the Turbo Expo in June. So our FlowNext team will be there. So a lot of our listeners I know in the turbo machinery business. So if you're going to Turbo Expo in Boston, do stop by the FlowNext booth and say hi to the PADT team there. And then I'll also do a little bit. It's again, this is a way off. It's in June, but let you know if you're in the Phoenix area or the Arizona area or nearby, and you care about e-mobility, electric cars, batteries, all that stuff. We're going to be very involved in the Arizona Technology Council's e-mobility and clean energy summit. So we're going to talk about solar. We're going to talk about wind. We're going to talk about electrical vehicles and transportation, and pretty much. And there's a if you don't live here, you don't know, there's a huge amount of companies that are doing work in that space, really cool stuff. And we're all going to get together and talk about it in the afternoon of June 27th. So do check that out. Just kind of a precursor letting you know about that. And that's pretty much it. You can always learn about our events that are coming up by going to our website and going to About and then Events. Well, I want to thank you for yet another listening to another episode of the All Things Ansys podcast. If you want to know what's going on in the world of PADT, don't forget to subscribe to our newsletter at www.padtinc.com/opt-in, and there's always a link to the latest podcast in there as well. Don't forget to spread the word. Let other people know that the podcast exists and that they might enjoy it, and subscribe if you have not already. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 117. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.